All right, let's start. Good morning again. Happy Tuesday. This is probably the last time I'm seeing you on this lovely Tuesday morning. Today we will go over your final exam review sheet. As usual, make sure you schedule your final exam. And considering everybody's taking finals, it is tight. So make sure you don't miss your time. It's so hard to reschedule if you miss your time. So please make sure you put lots of reminders and plan to be there early. There might be traffic on your way, there might be parking issues. Just plan to be there 1 hour early. That won't hurt you. All right. Our final exam will have approximately 22 problems, and multiple choice portion is 68 points. Free response portion is 32 points. You're going to have 110 minutes. So if you know the material, I don't think time will be any problems for you. Now, you know the extra credit, make sure you get a good score on practice finals so that you have a lot of extra credit available. And if you have completed course evaluations, I'm going to transfer those bonus points later on this week. How to study, we discussed this in class last week as well. This sheet should not be your only source. I have made a few folders for you. Go to the modules tab on Canvas, lecture notes, scroll down. At the very end, you're going to see a test reviews folder. Right next to it, it says final study materials, I think. So go to that folder. All your reviews and keys are collected there, including the review for the final. Today, I also posted the key for lab quiz 10, which is the last lab quiz you completed last week. It was a take-home lab quiz, and it covers important problems from chapter 6 for final exam purposes. So you are going to go over the reviews for test 1, test 2, test 3. The first, if I were you, I would do the in-class reviews first, and then if you have time, go over the online reviews as well. All right, so now you're going to start solving these problems together. At the end of this review session, I have time. If you have questions, I can answer them, okay? So for now, just try to follow me. If you cannot understand something, just message me on the chat box, and if I see the message, I will address your question. Later on, you can pause the video if you want to watch it slowly, okay? Are you ready? Shall we start? All right, so I will be in the review mode today. You know me, normally when I'm teaching, I try to do it slower, but this is reviewing. These are things we have learned, we're just solving them, and I want to get to all of these problems. So I will be in review mode. Message me on the chat box if you want me to explain something. All right, the first problem is a limit question from chapter 1. I should say this, all chapters are included, but from chapter 1, there will be maybe 1 or 2 limit problems. So chapter 1 is very light on the final. Plus, I should also add here that section 4.5 is not on the final, which is hyperbolics. Remember, we excluded that from the test, the corresponding test. Similarly, we are not going to ask any sine h, cosine h, sinh, cosh problems on the final, okay? So for chapter 1, review your limits, just basics. What's continuity? What's a right-hand limit, left-hand limit? It's just the basics from chapter 1, nothing tricky. If you see a limit problem, you know what to do. First of all, we need to plug in the target and see the answer. If you're getting a real number, that's the answer. Let's plug in 1. We get square root of 1 minus 1. 1 minus 1 equals 0 over 0. Now, in chapter 1, we learned how to solve 0 over 0 problems by doing algebra. We learned certain algebraic ways. Now that you also know about L'Hopital's rule, if you want, you can solve these problems using L'Hopital's. Now you have more options. You don't have to do algebraic manipulation now. So since it's a L'Hopital, it's a 0 over 0 problem, I personally prefer to solve it using L'Hopital's rule. In chapter 1, we were using algebraic manipulation and cancellations first. So according to L'Hopital, we do derivative of the top versus derivative of the bottom, derivative of the top versus derivative of the bottom. We rewrite what we have there and then plug in again. And we get our real number 1/2, which is the final answer. Okay, either chapter 1 methods or L'Hopital's rule is also fine, as long as you can confirm that it's a 0/0 or an infinity over infinity type problem. The second one looks a bit different. Limit as x goes to 0 of 5 minus 5 over x squared divided by 8 plus 8 over x squared. So here there is trouble about plugging in 0, right? You have to do what's 5 over 0, what's 8 over 0. So again, in chapter 1, we covered this with several options. I gave you a few options. One was perform the addition and subtraction upstairs and downstairs separately and cancellations. If you want, let's go with that. Let's do our algebra first. And upstairs we have 5x squared minus 5. Downstairs we have 8x squared plus 8 over x squared. And then if you keep the top, flip the bottom, you will see that there will be some cancellations. You can cancel this part and that part. And rewriting gives us 5x squared minus 5 over 8x squared plus 8. And then we plug in 0. And we end up with a real number, which is our final answer. So this is one of the options we covered in chapter 1. You see a subtraction going on here. You see an addition going on there. You can perform those. There are other ways of handling this, but since it's not a huge topic, I want to stop here providing you with one of the options. There are other ways of solving this. Just a side note. All right, the second problem is a limit problem again. Remember, step 1 in every limit problem is to plug in and see what you get. If you get a real number, you're done. Let's plug in. We have e to the 0 minus 0 minus 1, 1 minus cosine of 0. Remember, e to the 0 is 1, cosine of 0 is 1. These are must-know things for you. So upstairs we have 1 minus 1. Downstairs we have 1 minus 1. So we get an indeterminate form, but one of the good ones, right? This is a good one because you can apply L'Hopital's rule to it. And let's write LH. L'Hopital's rule says derivative of the top versus derivative of the bottom separately. Derivative of the top and then derivative of the bottom. And then plug in again and see if you solve your 0/0 problem. Plug in. Oh my goodness, it is still 0/0. That means we're going to use that one more time. All right, derivative of the top versus derivative of the bottom equals, let's plug in and see. 4 times e to the 0 versus 4 times cosine of, oh, by the way, you could have canceled those 4s, of course. So we have 1 over 1, which is 1. We have reached our final answer. We know we have reached our final answer once we get a real number. Okay, so this is a L'Hopital's rule question. It's very typical to apply it twice. Sometimes you're lucky, it works after one round. Sometimes you go to the second round. But please expect something like this as a multiple choice question on the test. Another limit problem. This time it says limit as x goes to infinity. So it's a pretend plugging in. Just observe what's going on upstairs, downstairs. Upstairs, the polynomial as x goes to infinity. Upstairs goes to infinity. Downstairs is exponential, e to the 2x. As x goes to infinity, e to the 2x also goes to infinity. So this is an infinity over infinity type indeterminate form. And again, good news, you can use L'Hopital's rule on it, right? So let's use it. L'Hopital's rule. Limit as x goes to infinity, derivative of the top versus derivative of the bottom. 2x plus 4, 2 times e to the 2x. And then, this is a fresh problem. As x goes to infinity, what happens to this expression? You'll see that it's still infinity over infinity. So it calls for another round of L'Hopital's rule. Let's use it. LH, I'm gonna write LH for short. You know what it stands for. You're experts on this now. Upstairs is 2, downstairs is 4, e to the 2x. First, you can cancel and say this is 1 over e to the 2x. And remember, as x goes to infinity, 1 over x goes to 0, right? Or you can consider this to be 1 over infinity approaches 0. 1 over 0 approaches infinity, and 1 over infinity approaches 0, okay? That's why you say this guy is 1 over, it's like denominator goes to infinity, 1 over infinity. The answer is 0. Do you have a question, Ali? I saw your hand for a moment. You can type your question in the chat box. If you think, if you catch a mistake, an operational mistake, let me know in the chat box. If you have a question, Ali, please type in the chat box. Oh, I forgot it too. I'm sorry. Okay. Thank you. But it doesn't change the answer, but yes, you're right. I canceled, but I forgot one of my twos here. Yes. But still, it's the denominator is going to infinity. 1 over infinity goes to 0 is the idea. Okay, thank you, Adi. I canceled and forgot to write 2 there. All right, so this is a recap of limit problems. I put all of them together. They're from chapter 1 and or from chapter 5. Okay, even if it's a chapter 1 problem, now that you have chapter 5 tools, you can use those ideas as well. Okay, so I put all. We're expecting multiple choices over these. And please go over review for test 3 to solve more L'Hopital's rule problems. Okay, so that is the end of the limit. And next thing is know the definition of the derivative. Interest. Can you hear me? So guys, can you hear me? Something is off. Let me change my intro. Can you hear me now? Okay. All right. Oof, that scared me. I am back. You see, online teaching always has issues, right? We have experienced this so much during COVID era. And I have two very strong internet connections at home, but still things happen. All right. All right, let's continue. So I was just saying that you should know how to set up the definition of the limit for multiple choice purposes. Can you answer a question like this one, the one you are seeing on the screen? What do you think? It's easy when it's just set up, right? So make sure you can answer something like this. You're looking for just the setup. Okay. Next, let's practice our derivatives. We have learned all the rules about differentiation. If you want to make a formula sheet for yourself while you're studying, that would be good for you, especially if you do some handwriting. It helps with your memory skills, okay? Handwriting is the key. And product rule, quotient rule, chain rule, remember those, and all of the others, power rule, trig functions, all of them. All right, I'm gonna be in my review mode. Stop me if you have a question or if you see a mistake, use the chat box, please. All right, this one is a product of two functions. So it calls for the product rule. Product rule goes like this. The derivative of u times v is the derivative of each one at a time. Derivative of 5x squared, keep cosine as is, plus keep 5x squared as is, and derivative of cosine. Okay, so your free response portion might have two problems, one with lots of derivatives and one with lots of integrals. So we might see such problems on multiple choice first and then on free response. Make sure you write your answers properly. When you use a negative like that, it's good to protect it with extra parentheses so that it doesn't look like subtraction. All right, another product rule problem here because it's x squared times tangent. Derivative of x squared, keep tangent as is, plus keep x squared as is, and take the derivative. Thank you. Oh my goodness, what am I doing? Let me sip my coffee. That technical problem threw me off. Thank you, Amina. Of course. Derivative of tangent of 2x to secant squared of 2x. Thank you for being careful. I am watching so many things at once, and making sure it's recording is kind of stressing me out. All right. And the next one is your typical quotient rule problem. And I expect a quotient rule problem on the multiple choice part, so make sure you can do this. Remember, u over v prime is u prime v, u v prime with a minus in between, and denominator squared. So f prime is derivative of the top times bottom minus top times derivative of the bottom all over bottom squared. Of course, on a multiple choice question, you cannot just stop here. You need to make this top simpler so that you can see what you have, you can match with your choices. So it's going to be 28x minus 14 and minus 28x minus 4. Don't expand the denominator. 28x minus 28x minus 14 minus 4. And then when you're done, look at the choices to see a matching one. Okay, so we're expecting product rule and quotient rule for sure. All your derivatives are important, sine, cosine, tangent, secant, all of them. Make a formula chart for your use. Do not bring it to the testing center, but while you're studying, handwriting helps. Continuing with the derivatives. The first one is about power rule, but it is helpful if you write each term with powers like that. So let's practice power rule for derivatives, for differentiation, because we also learned power rule for integrals. All right, 3x squared, 1/2 x. Take the power to the left, decrease the power by 1. X to the n derivative is n times x to the n minus 1. When we integrate, it is different. Don't forget that. Somebody is raising hand, but I cannot see who it is. Okay, you can use the chat box if you have a question for me. Next, sines, cosines, exponentials, and must know derivative of e to the mx is m times e to the mx itself times m. So always keep that in mind. Anitra, question 3 is quite in the past. Let's do that at the end, okay? Remind me. Which one is question 3? It's our... Okay, let's do it at the end. Stopito's rule is one of our typical easy problems, but if you want me to do it slowly, remind me at the end when we are done. All right. Derivative of sine is cosine of e to the 10x, but then chain rule says multiply by the derivative of inside. Derivative of cosine is negative sine. Keep the inside as is, and then multiply by the derivative of the inside. Okay, this is a typical problem. There might be several such problems. Next, secant. Derivative of secant is secant times tangent. Same inside, don't change the inside. But when you're done applying the formula, consider chain rule says times the derivative of inside plus tangent, change the name to secant squared, and then times the derivative of inside. Okay. All right, I did not type, can you hear me? But I guess one of my old messages is coming by. Okay, let me know if there's trouble, okay? All right, I'm checking with 2 connections. I have my laptop, I have my iPad, but still, if there's trouble, let me know. Continuing with the derivatives. Derivative of square root of u is important for us. I want you to know derivative of root u is u prime over 2 root u. That's a must know. Okay, so this guy is derivative equals derivative of the inside divided by 2 root, same as the problem. 2's get cancelled. This is your answer. Okay, and a practice on exponentials. It's very important for us. Derivative of e to the 2x is 2e to the 2x. Derivative of 4 to the power of 5x is itself times ln of 4 times 5. Chain rule says multiply by the derivative of the exponent plus exponential again. Is that cubic? Yes. Itself times derivative of the exponent due to chain rule. Okay. And ln is very important. Must know ln of u. What's the derivative? U prime over u. Okay, derivative of inside versus inside. So this is ln of x to the power of 4 plus 1. The derivative becomes 4x cubed divided by x to the 4 plus 1. And that's it. You don't do anything else. It's u prime over u. Unless there are obvious cancellations, that is it. And we must also know derivatives of arcsine and arctangent. Arcsine, arctangent. We must know them. All right, arcsine. Let me write it here. Arcsine of u. The derivative is u prime over root 1 minus u squared. Arctangent, u prime over 1 plus u squared. No square root on this one. Okay. So know your formulas, know how to apply them. The first piece, arcsine, 2x over root 1 minus x squared squared, 4 over 1 plus 4x squared. If free response, you can stop here. If multiple choice, look for a matching answer. Depending on how the choices are typed, you might see this there. Right? X squared squared is 4, and you might see 1 plus 16x squared there. Okay, it's possible. But if it is free response, it's good to go. Just stop here. Okay. These are our derivative problems. More, okay, more on derivatives. Oh my goodness, we practice derivatives so much, right? Cosine of a different inside. Derivative of cosine is negative sine. Keep inside as is. And when you're done, derivative of the inside, 4 itself times 5. Okay, this is fine, but of course on a multiple choice question, we will multiply these numbers out. 2, 4, 5, 40. And that's the answer, okay? Practice these. Now this was just cosine. If it has a power, we need to be more careful about it. This one is sine to the power of 6. So we need to be remembering this. If you have ugly to the power of 6, right? In general, and the derivative is, what is it? Power rule. And then derivative of ugly, right? So you need to consider this to be sine of x squared to the power of 6. Okay, sine to the power of 6. Same thing applies to cosine to the power of a big number. And I think there are a few problems like that, okay? 3 states, and we work on this part with power rule ideas. 6 to the left. 6 is becoming 5 because we're subtracting 1 times. Now we need to multiply this by derivative of sine of x squared, which is cosine of x squared times 2x. That's it. And I'm guessing this might be a Fourier response. Remember, this was a Fourier response on S2, was it? So a similar problem might be there. A power of sine or a power of cosine. Please practice this. Are we good? You're good? I want to make sure this thing is working. You're following me. You can see me. You can hear me, right? Elaine, yes. Cumulative meaning. Final is cumulative. So if R is cumulative, meaning what? I don't know. But the final exam is cumulative. It covers all the chapters. But as I said, chapter 1, only a few problems. Free response cumulative, meaning if the final is cumulative, free response is cumulative, right? But what do you mean cumulative? I mean, it can be any topic, but I'm telling you, expect a free response problem with lots of derivatives. Expect a free response problem with lots of integrals. All right, let's review something else. It can be anything, I'm telling you. One of it is derivatives. Derivatives is not chapter 6. Past topics, one is integrals. This is section 2.4. If you want to review this, you see a complicated formula of x's and y's, and you want to find dy by dx. A complicated formula of x's and y's, right? That calls for using a special technique, right? What did we call it? Implicit differentiation. We take the derivatives of both sides, but implicitly. All right, take derivatives. Take derivatives of both sides, but implicitly. Okay. Y cubed, the derivative is 3y squared dy by dx. Negative 10xy is like 10x times y. So it calls for the product rule. And 2x is derivative as usual, and derivative of a constant is 0. So this is taking the derivative. You want to find the slope of the tangent line at 5, 2, right? So you can plug in 5, 2 now, or you can first solve for dy by dx and then plug in 5, 2. Both are possible. Let's see. I'll solve for dy by dx because when I do it otherwise, students generally get confused. Okay. Solve for dy by dx. And dy by dx is this expression. And the problem says you want to find the slope at the point 5, 2. So your job is to plug in that. Dy by dx at the point 5, 2 is 10 times 2, 2 times 5, 3 times 4, 10 times 5. 20 minus 10, 12 minus 50. 12 minus 50 is negative 38, right? Negative 5 over 90. That's it. Question says find the slope of the tangent line. You plug in the given point, x coordinate for x, y coordinate for y. And I gave you an exercise that's similar here. so that you practice. So this is a multiple choice question. Make sure you practice. Okay. Next, we see some chapter 3 problems. Remember those skills we had covering how do you decide if a function is increasing, decreasing, concave up, concave down, how do you find local min, local max, etc. Sign charts are very important here. Given f of x is a polynomial with the derivative 2 times x minus 1 squared times x plus 4, find the intervals over which the function is increasing. The function is increasing when the derivative is positive, decreasing but when the derivative is negative. So basically, you want to make a sign chart for f prime. Okay? See the zeros of f prime because zeros are what we use on the sign chart. Okay? Notice that 1 is a special 0 is coming from an even power, but -4 is coming from an odd power. Okay? If you're using the shortcut I showed you in class, that matters. Put them in increasing order as if this is number line. F prime versus F. These are its zeros. Now you can either use the shortcut I mentioned. I made a post about with the video for this shortcut, or it's not hard to plug in. Pick something here, plug in here, plug in here, plug in. Just any value in that interval produces the same sign, positive or negative. That doesn't change. So it's gonna be, let's see, plus, plus, minus. And we're looking for increasing, so we need f prime plus, right? So function is decreasing, increasing, increasing. So our final answer will be f is increasing on -4 to forever. Because at 1, there is a pause, but considering the function is a polynomial, it's defined at 1. You just combine adjacent intervals. If the question said, when is f decreasing, you would just say -infinity to -4. And you can see similar problems in our review for test 2. There were many problems there covering different cases. So if the derivative is given, the question is increasing or decreasing. Your job is to use a sign chart for the derivative. F prime is positive, means your function is increasing. F prime is negative, means your function is decreasing. Okay. Another topic is concavity. And remember, your function is concave up if the second derivative is positive, concave down if the second derivative is negative. So you see a question about concave up. This is about f double prime. Make a sign chart for f double prime. Okay, concavity means sign chart for the second derivative. Okay, so this is the function is a polynomial, it's given. We need to find its second derivative. First derivative, power rule. Second derivative. Okay, now to make a sign chart for it, we need to find its zero. So set it equal to 0 and solve. Let's factor. So its zeros are 0 and -2, and let's make a sign chart. -2, 0, f double prime. Again, testing. Or my shortcut, you just pick something here, here, or here. It's plus, minus, plus. Conclusion. Our function is concave up, down, up. So where are we concave up? To finish that, you need to answer f is concave up on negative infinity, negative 2, and 0, infinity. And such questions will be multiple choice. You will see increasing, decreasing ones, and then concave up, down, separate questions. Increasing, decreasing ones are about sign chart for f prime. Concave up, down, sign chart for f double prime, second derivative. Okay? Don't miss those problems. Here I have a multiple choice question. MC means multiple choice, so these are your choices. That's what I mean, so that you don't consider them as separate problems. Let's say you have some information about f and you want to classify this point 1, 2. What you know is f of 1 equals 2, f prime of 1 equals 0, and f double prime at 1 equals 4. What does this mean for us? First, f prime of 1 equals 0 means x equals 1 is a critical point. Okay? Then, critical point means it can be a minimum or maximum, right? Or a cusp or whatever. Now, f of 1 equals 2 means 1 comma 2 is a point on f. So f is defined at 1. It is, if you have the graph, something like this, 1 comma 2 is a point on it. Okay, that's what we know. But considering it's a critical point, maybe something like this, or maybe something like that. We need to decide on that. The last piece of information says your shape around 1 is a concave up shape. So x equals 1 must be a local minimum. Because 4 is greater than 0, positive second derivative means your shape is a cup shape, which means your critical point must be a local minimum. So you pick that one. Okay? So there might be some dummy choices there. But the problem is really, it's the local minimum, it's the local maximum. And the name of this test is called second derivative test. How does it work? You take a critical point, you plug it in the second derivative. If you get a positive number, the critical point is a local minimum. If you get a negative number in the second derivative, critical point is a local maximum. We practiced this before. All right. But it only works on the critical points, okay? Don't misuse it. Look at the positive or negative and decide. All right. Another easy problem. Again, this will be multiple choice with function values. The problem says here are some function values. Write the equation of the line that is tangent to the curve at 1. Okay. So this is a function. We want to write the equation of the tangent line at 1. First, we need to know the point. What is the point? 1 comma f of 1. The information says the point is 1 comma 2. Second thing is we need the slope. Slope of the tangent line is the derivative at 1. And the information says the derivative at 1 is 4. So you have the point 1, 2, slope 4. You just say y minus y naught equals slope times x minus x naught. Y minus 2 equals 4 times x minus 1. But considering it might be multiple choice, you might have to do this so that you see your answer in the choices. And pick that one. Okay. This is about using the given information to write the equation of the tangent. Okay. Next. Absolute max min is a topic we covered in chapter 3. Remember, you see the word absolute max or min, there will be an interval attached. You need to figure out the critical points in that interval too, so that we test, right? We study. First, find the critical points, find critical numbers. So take the derivative, set it equal to 0. So you have a critical number 2. Now make a table of values, initial point, critical number, final point. So I'm getting those from the interval and plug in. Initial value is 9 plus 12 plus 1, 22. F of 2 is 4 minus 8 plus 1, 1. F of 3 is 9 minus 12 plus 1, negative 2. So among these, you're looking for max. So you want the largest. Max value will be 22. You're looking at 22, 1, and negative 2. Absolute max value is 22. Absolute min value is, if asked, negative 2. Okay? So some versions might say max, some versions might say min, just one of them, multiple choice. Compare the values, the largest is max, the smallest is min. That's it. Did I make a mistake, Ali? Yes, f of negative 3. Are we good with the answer? It says value. It's value, we just say the y chord. But if you see a mistake, let me know. Why? I don't think so. The interval is negative 3 to 3. So this is the initial value. This is the final, and this is the critical. Oh, that part. Okay, sorry. Let's see, 4 minus 8, negative 4 plus, okay, you mean this value. Okay. Oh, okay, that changed our answer. Thank you. Negative 2. So if abs min value is asked, the answer is negative 3. Abs max value is asked, the answer is 22. Thank you. Or minus 8 plus 1. Okay, I made a mistake there. All right. There will be a few word problems. Maybe rate of change from chapter 3 or optimization from chapter 5. I grouped them under rate of change problems. So under word problem. So go back to the reviews and practice both types. Here is a rectangle problem. The length of a rectangle is increasing at a rate of 5 centimeters per second, and the width is decreasing at a rate of 2 centimeters per second. At what rate is the area changing? Okay, so first we draw a rectangle. Pictures help, right? We give the variable some names. Let's call the length x and width y. Okay, information, the dx by dt is increasing, means positive 5. dy by dt is decreasing, means there is a negative rate there, negative 2 centimeters per second. And the question is, how fast is the area changing when the x is 12 and y is 4? Right? So it's about x and y are changing. As a result, your area is changing. How fast is your area changing? Okay. First of all, write down the area formula. Okay. And then say, I'm going to take the derivatives of both sides, but here we need to use the product rule because it's the product of two things that are both changing. Dx by dt times y, x times dy by dt. Yeah, this is what you need, related rates. Now let's plug in values. We want dA by dt when x is 12, y is 4. So that's what we're going to plug in for x and y. And how about dx by dt? It was given in the problem to be 5. So you're going to say 5. Y is 4. We are given here. X is 12. We are given to plug in 12 for x. And dy by dt is given as -2. That negative makes a difference here. Be careful. 20 minus 24 is -4. That is it. And this is our typical related rates problem. We did practice this a lot. Okay. Next, I have some write down the objective function questions. Remember, this is about optimization, which was 5.1. Okay, if you want to see the notes. Two adjacent rectangular gardens of equal dimension are to be built with a total area of 600. And let x be the length of the shared side. So first draw a diagram. It says we have a rectangle, two rectangles of equal dimensions. And we are saying x is the shared side. Let's give the others names like this. Okay, so that the each garden is x by y. Total area equals 600 means this versus that. It's x times y plus x times y is 600. So it's 2xy, which means y is 300 divided by x. That's the relationship between x and y. The perimeter is to be minimized, so your objective function is about the perimeter. Perimeter is normally, if you go around it, you're covering 3 x's and 4 y's. Just switch this y using this information. That's it. Look at the choices for something that looks like this. Okay. If it says write the objective function, you're just writing this to be minimized. You don't need to solve the problem. Okay. Write the objective function means write down the formula for what you want to minimize or maximize. Okay. Look at the choices for an equivalent form. This is our objective function. Stop there. Do not continue with solving the problem. It will be a waste of your time. If the question says, write the objective function, and this is the answer. Another similar problem that says, write the objective function. Be careful. Story. The story is, an open top box is to be made by cutting square corners from each corner of a rectangular plate that has dimensions 20 by 50. Remember this problem, we worked on it in class. We are cutting square corners like this of equal dimensions, of course, so that we can make a box out of this. And you can see our class notes for a nice visual for it. Originally, this was 20 by 50, but remember that you're cutting x, 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 x from each corner. So when you get to this picture, one side will be 50 minus 2x, One side will be 20 minus 2x, and the height here will be x when you fold it. So the objective function is maximize the volume. All right, so volume will be x times 20 minus 2x times 50 minus 2x to be maximized. That's it. It's a very easy question. It says write the objective function. Don't try to solve it. Write down the formula for volume, which is base area times height. Height is x. Base area is the product of sides. That's it. Okay. So read the problem before you know what you want to do, how much time you need to spend on it. If it says write down the objective function, this is it. Whew. We are there, chapter 6. All right. See lab quiz 10 and the key. I posted the key, and lab quiz 10 covers what you really need to remember from chapter 6 for final exam purposes. Again, chapter 6 is extremely important for calculus 2 purposes, but today I'm focusing on what you need to study for final exam purposes. All right, the first skill is about fundamental theorem of calculus. If you want to take the derivative of an integral function, there is a shortcut, and these problems that say d by dx and then an integral sign next to it are about that shortcut. We want you to use that shortcut. There is an integrand here. So this is about that skill. The shortcut is you go to the integrand function, the function you're integrating. If your integral boundaries are from a number to some x's, go to the integrand function, plug in the upper bound instead of t, and multiply the whole thing by the derivative of the upper bound. So derivative of the upper bound plays a role. So your overall answer will be this guy. And done. I know it's surprising, but the whole point is there is a shortcut. We want to use that shortcut. Otherwise, first integrate and then plug in the boundaries and then take the limit, take the derivative is unnecessary work. It produces the same answer. Here's another one. D by dx integral. This is your integrand function. What does the FTOC shortcut say? It says go to the integrand function, plug in the upper limit, and after you're done with the plugging in, multiply by the derivative of the upper limit. So your overall answer will be that's it. So it's multiple choice. Look at the choices for that answer. Please practice this, and there are some problems on your practice final, I believe, about this. Next, let's practice integration. The first question I have here is about integrating a polynomial, which means our basic rules. Remember, integral of x to the n dx is power rule, right? This is called power rule for integration. You add 1 to the exponent, you divide by the new exponent. This problem is definite, so we don't need this plus c on such problems. Power rule says this. Derivative integral of x cubed is x to the 4 divided by 4. Add 1 to the power, divide by the new power. Integral of 2x is x squared. Integral of 5, integral of a constant is linear, remember that, 5x. Because this is a definite integral, you do not need to put plus c, 0 and 1 here. Now it's time to plug in. Plug in the upper bound, upper limit, minus plug in the lower limit. And finish your problem by saying I need to do 1 over 4 plus 6, 25 over 4 is our final answer. I'm expecting an easy integration like this on multiple choice, and I don't want anyone to miss it. This is the easiest integral problem, right? Power rule, and then plug in upper limit first. And then minus plug in the lower limit. That's all. It's f of 1 minus f of 0. Oh, this just moved. I don't know it was going to be on the next page, but it shifted. It's okay. This is a good free response problem. It's indefinite. Indefinite means your answer will be a family of functions, and it has to end with plus c. But the good news is there's nothing to plug in. It's just finding the antiderivatives. Let's do it one by one. E to the x, the integral is itself. 5 to the x, the integral is itself divided by ln of 5. 4 over x, the integral is 4 times ln of absolute value of x. Don't forget the bars. 1 over x squared is considered to be a power function, x to the negative 2. The integral is add 1, divide by the new power. When you're done integrating, don't forget to put your plus c. And this is it. You see an integral sign. There are functions inside it with this plus that. Work on each term one by one, apply the formula or the rule to each term. Okay? And this is a good free response question, so practice similar problems. Another one, we have rules. You have to know, memorize integration rules. Remember, I gave you a table of integrals. Integral of secant times tangent is just secant. An integral of secant squared is tangent. When you're done, put a plus c. Indefinite. No boundaries means indefinite. Indefinite means your answer must end with plus c. Must. Okay? Next. This is a quick formula problem. First, pull the 16 out and think about it. What is the function whose integral is question there, Eric? You can use the chat box. It is. It's gonna, if you rewrite it, this negative one will make it turn negative. I just did not rewrite it. If you rewrite the whole thing again, you're gonna write it as minus 1 over x. But they're the same. Right? You're welcome. Okay, so this is a formula question. We should all know that the integral of 1 over 1 plus x squared is arctangent. Must know it's going to be there. Please study this. Arctangent. Let's see, done. If you know your formulas, some questions are quick, just this much. Believe me, something like this is there, that easy, okay? Another formula question. First, pull the 5 out. Remember, we can pull numbers out, but we can pull coefficients out, but not x's out. And this is our formula for arcsine. And plus c and we done. This is it. Those are the final answers, nothing to do. Okay? But please practice writing the integral signs too. It's very important to know these. These are what I call quick use-ups, but they're very important. They show up a lot, so make sure you know them. We will be using them now. Using these facts, integral of sine of a couple of x's, integral of cosine of a couple of x's, integral of e to the power of a couple of x's. The point is about these mx's, okay? M in the denominator, okay? Let's practice integral of 7 sine of 2x. 7 stays as the coefficient. You just work on integral of sine of 2x is 1/2 negative cosine. 4 stays, and then you work on integral of cosine of 5x's, 1/5 sine of 5x. When you're done, plus C. Okay, what am I using? Integral of sine is negative cosine, but there is a 1/m here because inside has a couple of x's. Integral of cosine is sine, but there is 1/m if the inside is a couple of x's. Okay, this is a typical problem. Can you do it? Can you do it on your own? Please practice this, practice writing this down. Okay, it's there, I'm telling you. It's very typical. All right. Another one, integral of e to the 4x is itself, but 1/4 shows up. Integral of 2, a number, is 2x plus c. When you're done, attach a plus c because you're looking for a family of functions. All right. Integral of sine of 10x, the fact again is cosine, but a negative. Integral of secant squared is tangent. Done. Okay. Integral of secant squared is tangent. Why? Because derivative of tangent is secant squared. Integral is antiderivative. Okay. Now, 6.4, u sub, very important. You have to know. Here is a definite example. We practiced this in class last week, very similar problems. This is u sub with u equals denominator. First, figure out what the derivative is. And we also like switching our boundary, the limit, so figure out the corresponding values. And 9. Okay, now we're going to apply u sub. And the problem will become x dx is equal to du over 10. And the new limits are 4 to 9. Let me write 4 is it 4? Okay, it's not random. We are applying the rule that we declared. All right, then 1/10 pulled out. 1/u du. And we know how to integrate 1/u. It's ln. Then we plug in our limits. We don't have to go back to x because we switched our boundaries. And this is it. Look at the choices for something that looks like this. So there might be a multiple choice like this, and then later on a free response like this, okay? My guess is the multiple choice might be definite and the free response might be indefinite, okay? So practice each, but I covered everything you need to know. The video is there, the notes are there, lab quiz 10 is there, its key is posted, you just need to study. And this is important for calculus 2 purposes as well. I created a multiple choice question for you that is asking you, oh yes, Saya, lots of them. I'm gonna drop 6. The syllabus says 4 quizzes will be dropped, but I'm planning on dropping 6 between us, okay? I only do that at the end once you're done with your quizzes. Yesterday, all quizzes are over, right? They're done. So now I can tell you. I don't say this before because then students skip taking quizzes. I want you to practice by taking your quizzes, but I will drop 6. Okay, so don't worry about it. Most of you will end up with amazing quiz scores, quiz averages. I'll draw 1 homework, 1 lab quiz, and 6 online quizzes. Okay. What's your answer? I'm tired. You answer this one. 22. It's a multiple choice question. Type A, B, C, D, E in the chat box, please. Apply the U sub and stop. You tell me A, B, C, D, E. What's the answer? Eric says C, Nus says C, David says C, Saya says, oh, you all say C? Okay. All right, so do you see that? You don't have to go all the way. It just says apply the U sub and stop, right? The choices make it obvious. We just want to apply the U sub and stop. It's a quick problem. You don't have to finish the problem. Okay. First, seeing this ugly cubed, say U equals inside, right? The base, whatever you see, of parentheses. So I'm saying U equals x squared plus 5, du is 2x dx, but I only have x dx available. So 0 to 1, this guy is becoming U cubed du over 2. But then let's switch the limits, right? Because it's a definite one. 0 will give us what? U equals 0 plus 5, 5. And 1 will give us U equals 1 squared plus 5, 6. So we're looking at the choices that we're looking for an integral in terms of U. It should have integral of U cubed du over 2. 1/2 can be pulled out, but very important, the correct limits are 5 to 6. So do you see the difference here? Okay, be careful. This is the right answer. We must change the limits according to the rule that we declared. Is that clear? That's a tricky part. So don't just apply the U sub, but keep the original limits. Okay? The rule applies to the limits as well. Okay, so I don't want anyone to miss this easy multiple choice question. All right, next. Let's focus on possible U sub problems. Again, multiple choice and free response, okay? So, I see this power here that gives me the sign. It tells me to try U equals this guy. The derivative is, oh, amazing. It is available upstairs. Great. And the limits, please. X equals 0 means U equals 2. X equals 1 means U equals 4. Okay. 2 to 4, 1 over U squared du. That's it. U sub has happened. Now we need to integrate it. We're going to integrate using power rule for integrals. Okay, if you want to rewrite before plugging in, it's basically negative 1 over U. Plug in. And final answer. Done. Okay. If it is free response, you must show the work. But if it is multiple choice, you have to do it with work. Do it on scratch paper. You cannot do it without the work needed, but be careful about showing work properly for free responses. Okay. Next is an indefinite one. So we're going to end with plus C. Okay. Okay, u equals x squared plus 1. du is 2x dx. But my problem has only x dx available. So I say this guy is, okay, u to the power of 4, u over 2, 1/2 pull dot, power rule applied. Add 1 to the power, divide by the new power, go back to x. 1 over 10. What was u? Plus c. Finished. Yeah. So this step is the u sub step. And this step is power rule for integrals. And this step is we have to finish the problem in terms of x. Our answer must be in terms of x, so we have to go back to x if it is an indefinite integral. Okay, so this is another possible u sub. The thing is, there are lots of versions of each problem, so I'm trying to cover every possible question you will see there. That's why we have lots of u sub problems on the review sheet. All right, this is a typical u sub again with integral of 16x divided by 1 plus x squared. X's versus x squared in the denominator is your typical, with u equals 1 plus x squared. du is 2x dx. What you have is 16x dx. So that's going to be 8 du's, right? You can do that inside the integral or in your work. Either way is fine. All right, so let's apply u sub 8 over u, du, pull out the 8. Coefficients can be pulled out. Variables, x's, u's cannot be pulled out. Apply the formula. Remember, this is a formula question. Integral of 1 over u du is ln. Right? Okay. Now go back to x. What was x? 1 plus x squared. And finish. Then don't forget these absolute values. That's it. We practiced this a lot last week. I solved many problems that end up with ln in section 6.4 notes. All right. Exponentials are also important. When you see exponential, the idea is if it is e to the ugly, you go to the exponent. U equals exponent. So we say u equals x squared, du is 2x dx as the work. Okay. And x times e to the x squared dx becomes u sub e to the u, and remember, x dx together is giving you du over 2. It's 1/2 integral of e to the u du. And now formula. The formula here is integral of e to the u is itself, just itself. As long as this is a single letter, same letter, it's itself. So 1/2 e to the u plus c. Go back to x. And finish. That's it. And remember, integral of e to the u du is e to the u plus c. Right, so if you see e to the power of anything but x, we try u equals exponent. And then a few more, almost there. All right, square root of ugly, u equals inside is the idea that works most of the time. Take the derivative, and we have x dx inside the integral. So u sub says root u, du over 2. And root u is u to the power of 1/2, so we can use power rule for integrals, of course. Okay. Don't forget to go back to x. Okay. 1/2 times 2/3, the 2's will be cancelled. Another one, x versus a square root of 9 minus x squared, but considering it's a square root problem, we go with u equals 9 minus x squared. It's the same drill, really. But this time, we need a -2, right? So let's apply u sub here. 1 over root u du over -2. Okay. And rewrite. Add 1 to the power, divide by the new power. Go back to x. That's it. That's our final answer. Okay, we did this. The video is available if you want to rewatch. And remember, quizzes 36 and 37 are your friends with USub. You have to understand this. I posted the keys to one version of each so that you can get some help from those. Again, these integrals may be definite or indefinite, and please try to understand when we need the USub, when we don't. If you see a number versus 1 plus x squared dx, this is a formula question that ends with arctangent. But if you see x over 1 plus x squared dx, this is your u sub with u equals 1 plus x squared. There is a difference here, okay? Versus. They're not the same, and I explained this on the video. All right, now let's talk about a few properties of integrals. Remember that integral and area are connected. If a function is positive, we can use its integral to find the area, but when the function is negative, we need to be careful. All right, this problem says the area bounded between the graph of f and the x-axis from -3 to -2. So here, the area is 11 over 6. Okay, and then from -2 to 1 here, the area is 9 over 2. This blue area is 9 over 2. And finally, is that it? No, 1 to 2. So if we go from 1 to 2, the third piece here is 11 over 6. Okay, what do they want from us? They want us to compute the integral from -3 to -2, is that it? Oh, interesting, it's that much. Okay. So if it is from -3 to -2, you already have the answer in front of you. What do you say? What's the integral from -3 to -2? Here, from -3 to -2, the function is positive. Yes, that's it. 11 over 6. Since f is greater than 0, integral equals area. Okay? If they said, what is the integral from -2 to 1? Then you need to be careful. Area is 9 over 2 means integral is -9 over 2. Okay? But if they said from 1 to 2, same drill. 11 over 6, because again, f is positive. Finally, just in case, if they say, what's the integral from -3 to +2? all the way to go from here to there. What do? One piece, another piece, another piece. Okay, so it's 11/6, -9/2, another 11/6. Okay, so depending on the interval you need to cover, if your function is positive, integral equals area. If your function is negative, integral equals negative of the area. If your function switches positive, negative over the given interval, you need to split it up. Okay? That's good? Can you handle it? If it's positive, integral is positive. If it's negative, integral is negative. Okay, one more thing about the properties. Given some information about f, can we find its integral at a certain interval? What's given? Integral from 1 to 8 is given, 2 to 4 is given, 4 to 8 is given, okay? And we want the integral from 2 to 1. First of all, integral from 2 to 1 is same as negative of integral from 1 to 2. We like smaller to bigger better, so just switch with a negative. Then, what's given? I like doing this on the number line. 1, 2, 4, 8, 10, right? What's given? 1 to 8 is given. 2 to 4, 10 is not even there, sorry. I need 10. 2 to 4 is given. 4 to 8 is given. And what we want is 1 to 2. I'm sure you can see the arrows now. The arrows are telling you what to do. To figure out what to do, you can say the whole thing minus 2 to 8, right? So you can say 1 to 2 is 1 to 8, the whole thing, minus 2 to 4 plus 4 to 8. Then you can find other combinations that might work, other ways to see it, but 1 to 8 is given to be 10, 2 to 4 is given to be 3, 4 to 8 is given to be 4, so your overall answer is 3 and minus 7. And this is about using given information and the properties of integrals to figure out the missing piece of the puzzle. Oh, this is 1 to 2, so we need to finish this problem saying 2 to 1 is, I almost forgot that, negative of this. Our final answer will be negative 3. Okay? Don't forget to switch. Okay, and this will be on the final, guys. Please practice this. Given a graph, you can use the graph to compute the integral if you understand the area connection. Function is positive, integral is area. Function is negative, you have to be careful, okay? So let's say this is a function f, and you want to find the integral of f from 0 to 4. Obviously, we don't have the formula, so we need area ideas. We say from 0 to 4, let's do some shading. From 0 to 4, this is the area we want, right? Can we use geometry to answer that, right? Just use area, since f is positive, integral equals area. Okay. So let's count our, we're just trying to figure out the area. If you want to use rectangles or triangles, you know, whatever you can to see the area of the given shape there, you can say there's a full rectangle here. You can use trapezoid ideas, whatever you can to answer it geometrically. Sometimes it's easy to count the squares, you can do that, but let's see. Let's do this. Let's do this as a rectangle. And these two guys as trapezoids, shall we? So we have a trapezoid here, 2, 4, and 1 there. So it is 1 times 2 plus 4 divided by 2. Then this rectangle is easy. 2 times 4 is 8. Then similar trapezoid, 3 plus 4 times 1. Okay, 1 times 3 plus 4 over 2. If you want to divide it up so that you have triangles and rectangles, that's also fine. 3, 8, and 7 over 2. So 11 plus 7 over 2, 29 over 2 is the final answer. Okay? Geometry, triangles, rectangles, trapezoids, whatever you can see there. But this works if the function is positive, right? If it is negative, we need to be careful. If it is positive and then negative, we need to split it up. The second part says 5 to 8. So how is this function from 5 to 8? Do you see that we have a problem here? Here and here. Integral here is negative of the area, so it's negative 1/2. But integral from 5 to 7 is same as the area, which is 2 times 2 over 2, 2. Okay? So we need to say it's 5 to 7 plus 7 to 8. And 5 to 7 is 2. 7 to 8 is negative 1/2. 2 minus negative 1/2 is 3 over 2. So it's net area, accumulated net area. If there's a negative side, you need to be careful about that. This is important. Are you good with this topic? It's going to be on the final for sure. And lab quiz 10, you have a question like this on there. And here is an exercise that's similar for you to practice, and that is it. Oh my goodness, we are done. Good luck on your final. And congratulations on finishing Calculus 1. You did a good job on all your tests. Now you need to do this one more time on the final. Trapezoid is, if it's the right trapezoid, guys, base 1, base 2, height, it's height times base 1 plus base 2 divided by 2. But it can be split up further into a square, a rectangle, and triangles, if you don't know that. I was just trying to save time. If you want to split it up further, you can create a rectangle and a triangle. So if you don't remember the trapezoid formula, it's fine. There are rectangles and right triangles. Yes, I will post the completed notes today. And here's an exercise for you to practice. I want you to practice this area skill. It's very important. So the key will be posted. And today, if I can find the time, I will take care of the drops. I will be dropping a huge number of 6 online quizzes, 1 lab quiz, 1 homework. So that will help you with the overall average. Now you need to do well on your final. Final replaces the lowest test after counting as the final. So it's great, guys. You have a lot of chances to improve your overall average. If it is not already an A, you can still improve it, okay? The important thing is study, study, study for the final, and don't miss it. So plan to be there early. The schedule is very tight. If you miss your time, it's going to be very hard to find a new slot because I know everybody, all math classes are taking a final right now. Sure, Anitra, we can do that. You're welcome, guys. Have fun in the summer after taking care of your finals. Have a wonderful summer. Good luck. So Anitra, now if you have any questions, please stay. Let me stop the recording so that it's not extra long. And then if you have any questions, I can answer them. And I will not see you. This was our last meeting together. So have a wonderful summer. It was great to know you. And good luck. Good luck. I wish you the best on your finals. After the final exam period, have a wonderful summer. Now I stopped recording.